This video details how to use the glass catalogs in the handy calculations pages. Before watching this video, it is better to have first watched the video processing calculations. In some calculations, the refraction index or the constraints are input parameters. The user can either define them by a number or by glass reference from a catalog, like in this page. The catalogs page can be reached by clicking on the menu General Parameters and on the topic Catalogs. On the left of this page, several links to catalogs are available. After choosing a catalog, it is possible to select a reference in the glass cell and calculate its refraction index at the wavelength that is entered in the lamp cell. Several constraints and the lowest wavelengths ensuring an acceptable transmission are also displayed. This page helps the user to select a reference and to check that it is adequate for a chosen calculation. Let's go now to a calculation page requesting to enter a refraction index. For that, let's go on the page Angular size of equal inclination rings. This page calculates the angular size of equal inclination fringes produced by a plane parallel plate illuminated with a diverging wave. The wavelength is an input parameter, its parameter lam. I can enter a glass reference instead of a number in the refraction index value cell, which is the N cell. The refraction index used in the calculation is then the one of the glass reference at the entered wavelength. In some pages, the wavelength is not an input. It is the case of the page Plane Parallel Plate Redshift versus Angle of Incidence, which is related to the aberrations of a plane parallel plate. In this case, when entering a glass reference in the refraction index cell, the refraction index used in the calculation is the one of the glass reference at a wavelength by default displayed on the top of the input table after processing the calculation. This wavelength is here 0.55 micron. It can be changed in the wavelength page that can be reached from the General Parameters menu. In this page, modifying the value of the lamp cell changes this wavelength by default. That is what I am doing now. Note that if a wavelength is an input parameter of a computation page, the entered value is then registered at the new default wavelength. For instance, if I go back to the calculation page related to the equal inclination fringes, and if I initiate a calculation with a new wavelength, this wavelength appears now as the default wavelength, as you can see in the wavelength page. In this page, two other parameters can be changed, lam-min and lam-max, which are respectively the minimum and maximum wavelength, defining the default spectrum used in the calculations related to chromatism when refraction indexes are defined by glass references. Obviously, lam-min is necessarily smaller than lam, which is necessarily smaller than lam-max. As an example, let's go now on the page calculating the height and axial chromatism of a real lens. If a glass reference is entered in the NL and NS value cells, which are the refraction indexes of the lens, respectively at the lowest and largest wavelengths of the considered spectrum, these wavelengths will be respectively the minimum and maximum default wavelengths discussed before. They appear on the top of the input table after processing the calculation. Obviously, numbers can also be entered in the refraction index cells. When the constraint is an input, It can also be either defined by a number or by a glass reference. For instance, if I switch to the page calculating the axial and height chromatism of a thin lens, I can enter a glass reference in the constrangence cell corresponding to the constrangence of the lens, and the calculation is then processed with the selected glass constrangence. Now let's come back to the catalogs page. You can see that among the catalogs there are two which are not catalogs from manufacturers: generic and theoretical. The theoretical one contains data on fake materials that don't correspond to any real materials. However, this data are realistic. This catalog is opened to any user without logging. The generic catalog contains data on generic materials, like for instance fused silica. It is accessible at least with a student license. All other catalogs, which are manufacturer catalogs, can only be fully used with a premium license. There is a restricted access for users with a student license. Thank you for your attention.